All right, what if we looked at area, what if we want to find the length in a polar curve? So how do we find arc length if we're in parametric form? We've looked at this, that would be from A to whatever our B is here, and we'd have the square root of our dx dt squared plus our dy dt squared, and that and we'd be integrating with respect to t. What would that look like if theta is our parameter? Well, it'd be the very same thing here, and we'd have that this, instead of dx dt, this would be x d theta squared plus dy d theta squared, and then we'd be integrating respect to the angle theta. So that is one way you could find arc length. But what if you are given stuff in terms of r and the angle, and it would be difficult to find dx d theta and dy d theta? Well, we can do a little bit of conversion here. So let's see what this would also be equivalent to. So first thing we're going to find is what is our 2 dx d theta and dy d theta. So let's start with dx d theta. So dx d theta, if we integrated this with respect to theta, what would that be equal to? Well, we would have to integrate this side then too. So we're going to have to do product rule since we got two functions being multiplied there. So we would have let's keep r, and then what's the derivative of cosine? That would be negative sine. And then plus, now let's switch them around. So we'd have cosine times derivative of r. Well, derivative of r is 1, but we'd have to include here that we're finding this, that's the derivative of r in terms of theta here, dr d theta. Just simplifying this a little bit then, this would end up being equal to negative r sine theta plus, I'm going to write the dr d theta first, dr d theta cosine theta. All right, let's do the same thing now, but with y. So what is dy d theta equal to? Well, let's do product rule again. So we got r times sine of theta, which is cosine theta. Now we're switching them around. So we got sine theta times derivative of r, which is also, again, dr d theta. So that would be it. And again, I'm just going to write this, clean this up a little bit. I'm going to write the dr d theta first. All right, so what then would all this be equal to right here, the part under the square root sign? So I'm going to write that out next here. So we would have our dx d theta, which is what we got here, squared. So, and we know that's going to be equal to this. So we're going to have negative r sine theta plus dr d theta cosine theta all squared plus, now we're doing our dy d theta here, which is all this stuff. Oh, I forgot the sine theta, all that squared. Okay, so we're just taking now and we're writing this here. All right, so what is this all going to simplify to? Well, what we're going to do is we're going to actually multiply two of these out and FOIL them. So what do we get if we FOIL those out or multiply two of them together? If I multiply two negative r sine thetas together, I'm going to get r squared sine squared. And it'd be positive because I'm multiplying two negatives together. If I multiply these two together, and then I'd also multiply another one of those two together, I would get two of those, and it'd be negative, so negative 2 r sine theta dr d theta cosine theta. Plus, what if I multiply two of these together? I get dr d theta squared cosine squared theta. So that's what I get if I multiply two of those together. Now let's do the same thing with these other ones. Quickly running out of room here. All right, so if we squared this other part, I'm going to get r squared cosine theta if I multiply two of those together. I'm going to multiply two of these together twice, so it'd be plus 2r cosine theta dr d theta sine. And then finally I'd multiply two of these, which would be dr d theta squared sine squared. Okay, so that's foiling both of those out and having them added together. All right, well, what do we have that might simplify here? Well, if you look at these two terms, this one and our last one, not all the way up that far, second to last term here, these two should simplify. They're the exact two same things. 2r, there's a cosine theta, there's a sine theta, there's a drd theta. Those would cancel out because they're the same two terms, one positive, one's negative. So we'll start by canceling that out. So now we got r squared sine squared theta plus this. And finally plus this. All right, what else can we do now on this one? So next thing we're going to do is rearrange this. So I'm going to write the two that have the r squared next to each other. I'm also going to write the two that have the dr d theta squared next to each other. And then I'm going to do some factoring here. So if on this one I factored out the r squareds, what we would get is r squared times sine squared theta plus cosine squared theta. And here I'm going to factor out the drd theta squareds. And if I did that, what's left over is cosine squared theta plus sine squared theta. What is sine squared plus cosine squared? That's that Pythagorean identity that we know is always equal to 1. So what we end up with, if this equals 1 and this equals 1, is that we just get that this is equal to r squared plus drd theta squared. And so another way to write this out is if we replace all that stuff under the square root with what we just found, this is another way to find arc length in polar form. So you can use either that first one we had where it's dx d theta plus dy d theta squared, or you can use this, which is our r squared plus our dr d theta squared. And that's two ways you can find arc length in polar form from A to B.